Actually, before I go to the website, I'll make a quick diagram right here. Um, let's imagine that I'm sampling from the JFK population. I'm interested in the mean, um, let's say I'm interested in the mean height of all JFK students. I'm interested in what the mean or average height of the JFK population equals. And I randomly select 30 JFK students to be my sample. I record their 30 heights, and then I calculate the mean of my sample by adding the 30 heights and dividing by 30. The sample mean that I end up calculating will be one sample mean inside of a distribution of all possible samples of 30. And we know that since I'm using a sample size of 30, the possible samples will follow a normal distribution, or at least roughly follow a normal distribution, even if the population is skewed, even if the individual people have a skewed distribution of heights. So here we have the population mean, which is the mean height of the entire university, which I'm trying to estimate. And it's actually unknown, which is why I'm trying to estimate it. But let's pretend that even though I don't know what the population mean equals, let's pretend that it actually is 60 inches. That's the average of the university. If I end up selecting a sample of 30 people, and the mean height of my sample ends up being 60 inches, then the mean of my sample equals the mean of the population, and I've perfectly estimated the mean of the population. And if that's what happens in my study, then my sample mean is directly above 60, right here. It's right on target. But there's more than one possible sample of 30 JFK students that would give me a mean of 60. For example, what I mean is there's other possible samples of 30 out there that would also give me a sample mean of 60, um, right at the population mean. So all of those possible samples of 30 that have a sample mean of 60 are all stacked above each other right here. So if I get this group of 30 people, my sample mean equals 60, and I've perfectly estimated the population mean. If I get this group of 30, my sample mean is equal to 60, and it's perfectly accurate. If I get this group of 30 people, the sample mean is perfectly accurate. Again, so these are all showing different groups of 30 people. This is a different group of 30 than this is. This is another group of 30. This is another group of 30. It just happens to be that all four of these groups of 30 all have a sample mean of 60. So it's four different groups of 30 people, but all of them have a mean that's perfectly equal to the population mean of 60. These are four samples, four possible samples that are all perfectly accurate. And if I get one of them, I've perfectly estimated the population mean. But down here, we have all of the possible samples of 30 that would give me a sample mean of 55. And they're all stacked above each other. Here's one group of 30 with a mean of 55. Here's another group of 30 with a mean of 55. Here's all of the possible samples that would give me a mean of 65. They're all stacked above each other too. So here's a group of 30 people with a mean of 65. Here's another group of 30 people with a mean of 65. And What I'm hoping is to get a group of 30 people with a sample mean somewhere in the middle, near 60. Because if I end up selecting a sample somewhere from this middle area right here, then my sample mean is close to the population mean, and I have an accurate result. But if I end up getting a sample of 30 people with a really low sample mean down here, then I have an extreme outcome that's not very accurate. If I end up selecting 30 really short JFK students to be my sample, then my sample mean will be low, and it'll be way down here. If I end up selecting a group of 30 really tall JFK students, my sample mean will be really high, and my sample will end up having a really high sample mean out here. So here's a shorter group of 30 people with a low average. Here's a tall group of people with a high average. But if I'm selecting a sample, if I decided to select a sample of 30 people, each possible sample that I could select under this curve is a sample of 30 people. Because if I decided to use a sample of 30, I'm definitely going to get a sample of 30 people. I'm not going to end up getting a sample of 40 people. So like I said, once I've decided on a sample size of 30, then all of my possible samples under the curve are just different possible samples of 30. That's 30, that's 30, that's 30, 30, 30, 30. Now I'll actually go to that website that I was talking about